Hey everyone, welcome to another technical stream of this Global Hack Week. This week we are featuring AI and machine learning. So this is very interesting because I know all of you are very, well, at least most of hackathons that I've been to are very excited about these topics, and it was time that MLH organized a week dedicated to this. So, first of all, greetings, everyone. Good morning, good afternoon, good night. For example, for me, for my time zone. Don't forget to check in. I already sent the link on the chat. It is very important for you to check in because you will be earning your week's points, and this will eventually earn you swag when you complete the challenges or you attend the live sessions and so on. And that's basically how it works. Hello, 404. Moises, hi. Oh, dinosaur sticker. Hi, hi. Okay, everyone saying hello. That's very nice of you all. Actually, I love AI ML Week so much every year. Yes, I mean, in my opinion, I think it's the one that gets hackers very excited. It's one of my favorites, to be honest. And also, I think there's one coming up dedicated to APIs. I also like that one a lot, and the one related to cloud, which I think already passed, not very sure, but yes, I also like that one very much. And well, I like this one that is AI and ML, especially because I love to talk about LLMs. I would say it's my favorite topic. Not very sure. I'm not very sure if it's LLMs or APIs because I like explaining how APIs work very much because I work with them on my daily basis. These API and Career Week are very popular with the hackers. Yes, API is also one of the most famous ones. Career Week as well. Also Beginners Week because in the title, it is like beginners week, so a lot of first time hackers get very excited to kind of see like beginner streams. But if you have been to my previous streams or have seen me the Global Hack Week, you should know that I always like to introduce everything in a very beginner friendly manner, and I also go on a little bit more in depth for those experienced hackers who are watching my streams, so everyone feels included while we are watching. And I'm always looking on the chat, and I always love to answer questions and make sure that everyone that is following along towards our exercise actually finishes like the project that we are building on stream, so everyone gets the final product that I will hope everyone gets to. I'm looking forward to Cloud Week. Oh yes, I mean, I think that's coming up. Is it? Let me actually check that because now I'm curious about the next Global Hack Weeks that are coming up. Yes. So, oh, that's so true. So, Cloud it's on March 7th. Wow, that was so fast. Okay, this is so nice because this week is AI and machine learning, and then on March we have Cloud, which is also one of my favorites, and then on April we have APIs. So I will try to be streaming a lot on the one of APIs because I think I have a lot of content prepared for that one. Awesome. Oh yeah, Jan is also the one of the New Year resolutions. A lot of hackers coming up. Yes, like wanting to code. Nice. It's my first time in hackathon. Oh, that's very nice. Nice. I mean, this is Global Hack Week. We like to call it more like a hacker festival because we include I mean, we give you challenges and these technical workshops on live streams for you to follow along. But I mean, it's not like a hackathon because you don't have to stay up like 24 hours without sleeping. It's more relaxed. So we call it Hacker Festival. Nice. Back to back. Nice. Yes, thank you. Okay, so first of all, I will share my screen so we can get started. But before I do that, I want to let you know that very sorry for canceling the stream that we had yesterday. I had a lot of homework to finish, and I always like to be at my best when I give my technical streams and have like a lot of content prepared for you. And at that time I hadn't prepared all of the content that I wanted you all to have. So I was like, okay, I can give the stream, but it won't be. Oh, I think, I don't know if it lagged, but my screen just froze, so I'll just wait a second for it to real. Oh, there we are. Awesome. Okay, it wasn't my internet. I think it was something about the live stream. But yes, I'm back. Okay, I think it didn't cut off. At least, yes, the stream is still going on. Awesome. So, what was I saying? Yes, that as you all know, on my streams, I always give you like super cool slides and like the GitHub repository and like a project to work on. So yesterday, I felt that I wasn't like completely, sure whether I would make it. So I decided to postpone it for today. So today we will be starting with part one of creating your first recommendation system. I know this sounds kind of like machine learning if you all have been a little bit familiar with recommendation systems in machine learning. But on this stream, we will be going more towards the AI side, especially with embeddings and tokens and some of their models that are there out there for us. So yes, I mean, let's get started. If no one has any more questions or comments, and I'm assuming you all already checked in because I really want you to get your points. So let's begin. I will present my screen now. Oh, okay, here we go. Awesome. So let us start. I think I haven't introduced myself, so I always include this. I think most of coaches include this slide at the beginning, at least to have some context on who you are watching on stream. And yes, So my name's Jocelyn, as you all might already be assuming. I'm a coach at Major League Hacking, and my pronouns are she, her. Some of my fun facts: I like salsa dancing and Minecraft bee plushies. I have a huge collection in my room. I think they're not visible right now because I have the background, but I will show them probably later on. Not on this stream, but probably later on future streams. It will be kind of like a surprise for those who are watching. If you want to talk to me about something random, you can ask me about mechanical keyboards, robotics, because I study robotics at university. I'm a second year student at university. I'm also based in Mexico, so that's another thing. And I'm a GitHub campus expert, so you can ask me about anything related to GitHub or AutoCAD, and I will be very happy to guide you through or just to chat in case you all want to talk to me about something. Yes. Hi. Oh, yes. Audio and video check. Thank you very much. Okay. So, what are we will be covering today? So, firstly, we will understand some basics about LLMs. I will go like very fast through on this because we already had, I think, another technical stream related on this. So I will just give you the basics to get you started on the context about what we'll be talking today. And then after that, we will learn a little bit more in depth about what are embeddings and especially how tokens are related to those embeddings. So, on this second point over here, we will be actually getting kind of like into the maths. It would not be very complex, I promise, because this is not a math class, but I just want you to have like the whole overview of what we will be working on the project. And finally, we will be setting up our Streamlit environment because we don't only want to have like a Python script. We want to have like a super nice dashboard where we can present our project so you can use it on your portfolio or as personal project. Kind of like to brag to your friends. So yes, we will be using Streamlit, and I think on the part two we will also be using MongoDB. I don't know if on this stream we will have time. Probably we will. Not very sure. So yes, okay. I think this is a really dumb question. No, no worries. No question is dumb. I'm sorry for that in advance. But is salsa dancing related to salsa? Okay, this is okay. That actually made me laugh. I mean, it is the same word. Yes, it is the same word, but it is like I wouldn't say they are related, even though it's the same word. But it's like a type of dance. But yes, the word is the same. I wouldn't say it's like completely related. But yes, that was a very funny question. It made me laugh. Hi. No, Matt. Don't worry. So we will only be seeing like two slides, and it will be about vectors. Honestly, I wouldn't consider myself a huge math fan as for school, but when I see it related to AI and machine learning, I actually like it because it's interesting to see like the actual application of it. Then we have some math lovers here too. Math lovers, okay, made with math. Okay, awesome. Vector embeddings, yes, that is completely right. We will be seeing that today. Okay, so after this session on part one, you will know what are embeddings and how they are involved in recommendation systems. So I know most of you have already heard these types of projects that are related to recommendation systems, probably like Netflix movie recommendation or music or movies or articles, news blogs, kind of like online content that you can recommend to someone. And there are different types of algorithms that you can use to recommend that to people. Usually, how it works in machine learning is that you have like your super large files of data with, I don't know, like thousands of movies and their ratings. Like, I don't know, like the Titanic is like 4.9 and so on. And it's like a long list of ratings, and then you have like your users and you start matching like recommendations between them, and you can use different types of algorithms to match that because you have trained the algorithm to learn what are the common ratings and trends in between people and which users will be basically more will tend to like which movies less than other ones. And there are a lot of concepts in between there. Probably I'll make another um probably later on another technical stream we will be talking about these other types of recommendation systems that are with machine learning. But on this stream we will be talking about recommendation systems with AI. Jocelyn, will we make our own model or use an already model? So I would say this is not machine learning, but we will be using a model that it's for tokenizing, which is a part of the embedding process. So yes, I mean that will count as using someone else's. I remember solving a linguistic puzzle back in 2017, way before the AI boom. Oh, that's so true. And I was just about vector embeddings, and that took me a month to solve by hand. Wow, that's super cool, actually. I actually remember it when I was in, I think it was my last year of high school. I was also learning about that, and I remember I tried to make like a recommendation system by hand, like get to match like certain movies with different like vector values to different users. And I was going through the formulas online just to see like the numbers actually matched. I mean, it wasn't necessary. Like with programming languages, you can do that like super in an instant, but I just wanted to do it by hand because I wanted to feel like kind of like very smart. It was not a big deal, but yes. Hopefully the models won't be huge. DeepSeek. No, we won't be using those. No worries. Okay, so first introduction. I have already used this image on another stream. I know if you have been to another stream of mine, you probably have seen this image again, but it's because I like it very much. Um, because we need to understand that an LLM is a type of artificial intelligence. So it's inside this like super huge core of things that they are out there about AI. So AI is kind of like the main thing that involves everything, right? And then we have machine learning, which is basically related to pattern recognition. That's why machine learning is directly associated to recommendation systems. So yes, because they learn patterns and they can recommend different trends to people. That's why it's more related to pattern recognition. Then we have the deep learning with neural networks, and it's basically called deep because neural networks, if you compare them with those in your brains, they are like complex relationships of neurons that interact with each other, um, and they have different layers, and the more layers that you have, the deeper your algorithm is. That's why they're called deep learning. And finally, we have LLMs, which are inside our super huge ball of things. And these are large language models, which are basically there for us so they can understand natural language. In natural language, um, it is basically how we talk, how humans speak and interact, and they can understand that and produce a response. That's why they are so famous, because you can interact with them as humans. I mean, you cannot interact with a neural network the same way that you will with an LLM. I mean, that's different. So yes, okay. I think there's a huge side talk over here. So let me highlight some messages. Okay, I already read this one. Me with my old 4 GB RAM. Oh yes, with Llama. I think the first time I run Llama locally, it wasn't a good computer, so I wouldn't say it took long. But when I tried running it on the one that I'm using right now, I wouldn't definitely recommend that at all. Hugging Face is a good send, and I get free credits from Hack Club. Oh, that's so nice. Hack Club is nice. I'm actually trying to get involved in there, but I think I haven't had time with everything. There's a lot of things going on, so probably Hack Club will have to wait. But that's so good. Not exactly, but you can participate in events. So true. I got like that's so nice. 200 total credits. That's super cool actually. I mean, I usually get my API credits, like for example the OpenAI ones, which are the, kind of like the most valuable ones, from hackathons where OpenAI sponsors and they give you like some type of cash amount worth of credits. Okay, but I hope everything's clear with what LLMs are, because now we will be going into this diagram that might look very weird at first, and I will not explain exactly everything of what's going on right now, but I will be explaining these throughout our stream. And what I want you to understand from this image is basically the process that an embedding follows in order to produce a response. So basically, we have our regular sentence, as we have in here: boy is walking, girl is walking, I am studying, and so on. This is a regular sentence, right? That probably I can say, or probably that someone else can say. It's something that is written in natural language that a human can understand. Then this sentence goes through a box, and in this box is basically a model, an embedding model. And what this embedding model, what it does is that it basically transforms this sentence into a array or a vector of numbers. And these numbers can either, I wouldn't say they're random numbers. I will explain where these numbers come from in a second, but I just want you to know that this sentence is then converted into numbers, and then we can actually find the relationship in between these different sentences depending on their meaning and their similarity. Not only like their how would I say, like their spelling or grammatic similarity, but like their semantic meaning. So that's why boy is walking, girl is walking are similar, and I am studying. It's kind of like all the way over here because it's not very similar to these two statements. So yes, everything that you have to know about this slide is just that embeddings are converted into numbers, and then those numbers represent how similar those three different sentences or statements are from each other. Yes, and now we will go very specifically on each one of these steps for you to know. And after seeing this image, you should now know where the recommendation parts goes on, right? Because if you have like a pair of sentences over here or a pair of statements on the left, and then you pass it on into your embedding model, and you will get how similar they are. And depending on how similar they are, let's imagine these two statements are movies, then I will recommend these two movies to someone who likes a movie who is plotted probably like over here on our Cartesian plane. And that's where the recommendation part comes from because they are similar. So it is more likely that I will recommend something from this part to someone. I saw an Alex net video and it showed me something similar. That's nice. Yes, I mean this is kind of like the best way to express how embeddings work. So I'm pretty glad you have seen these already. The last graph looks like KNN. Yes, I mean it's very similar. I wouldn't say it's the same because basically the K nearest neighbor, what it does is that it compares like a singular plot with like all of the distances over and over again. So when you add like a new plot, it basically computes like all of the distances in between points, and this is done like beforehand. So beforehand you get like the vector with the embeddings, and then they are plotted depending on the embedding model that was created, but they don't take into consideration the other neighbors, if you would like to see it that way. Yes, but if you were just talking about the graph, yeah, it kind of looks similar. You're right on that. Okay, so I know probably we all have used ChatGPT sometime. Probably not the API, but at least like the chatbot. And if you have used the API, you have heard of, or any LLM API, you have heard of what tokens are, or at least heard something related about tokens. I mean, I'm not very sure, but I know the word tokens is out there when you try to use any LLM API such as GPT, Gemini, DeepSeek, even if you would like to say it like that. So what we have to learn about this is that before we talk about all of the embedding things and get into more complex things, we have to start with the tiny little things that go beforehand all of this process. So what tokens are is basically, or tokenization, if you would like to see it as a process, is basically breaking down our sentence or statement into smaller units. And these smaller units are called tokens. And these tokens can either be words, characters, subwords, any kind of like chunks of data from my complete statement. So I included this snippet of Python code in here that says example of simple tokenization. So in here we have our text. It is just a normal text that says I love programming in Python. And then what we are doing is that we are converting this into tokens. So this is nothing more than parsing our statement. So we are basically dividing it into smaller chunks. So in here we have I, then we have love, then we have programming, and then Python. And if we can see, we only separated our sentence into different chunks or tokens. So as for now, you should know that tokens or tokenization is a process of breaking down a sentence or a statement into smaller units, and those smaller units are called tokens. Um, Probably right now you will be wondering like, okay, and why do I have to do this? I mean, is this really like necessary? Like what? Like where am I going to use this? So tokens will be used for our embeddings model, and we will see it later on when we start talking about embeddings a little bit more in depth. But for now, it is important that you understand what tokens are and what tokenization is. Try to remember that word because I will be mentioning that word later on the stream. And now when I mention it, you will now know that it is only parsing like my statement or my sentence or my content or information or whatever I am using, right? Tokenization reminds me or of parsing done in languages. Yes, that's right. I mean, it's only like parsing, splitting the text into smaller chunks, and basically all. I wouldn't say yes. Most of LLMs work like that. I mean, they have their own tokenization processes, and you will see where are those used later on this stream. So now being a little bit more technical about why tokenization is important, and now you should understand what tokenization is. So I won't explain it further on. This is because tokenization basically transforms human text, as we read before, into a format that an LLM can understand. So we tokenize our content so ChatGPT can understand it. If you would like to see it as an example. And yes, a tokenizer breaks down text into tokens and converts them into numbers. That's everything it does. I mean, this is a super nice definition. I would like you to stick to this definition. A tokenizer breaks down text into tokens and converts them into numbers. That's super straightforward, and it tells you what basically it is without any extra sugary things to know. And then these numbers are used by models to perform calculations. So these are not just random numbers. These numbers are things. It's a special language that machines can understand in order to perform calculations by the model that we would like to choose or that we specified for it to use. And in here we have an example of the 3 steps. So this is my input text. Write an email apologizing to Sarah for the tragic gardening mishap. Okay, that's a funny sentence. I don't know where I got that from. Okay. Yes, so this is a input text. It is a regular statement, and then it goes to tokenization, which is just basically parsing. Okay, so remember we only divided. So we have our letter right, then we have and, then we have email, and so on. Okay, so let's imagine we already tokenized all of my statement. And then we convert our tokens into IDs or numbers. So write will be this number, email will be this number, and so on. So now we have that every token has a numerical value. So my model will now understand that in order to perform calculations, right? So this is why tokenization is important, because it actually divides the content and parses it to the model into a numerical form that our machine can understand. I hope this is a little bit more clear with this example. And if you have questions or comments about this, you can always let me know on the chat so I can probably go slower or faster if I'm going too slow. That's also valid. I mean, probably right now a lot of experienced hackers are watching this, and probably this is like too newbie for you. So just let me know, and I will try to do my best for you. What is Sarah's? Okay, yeah, that's so true. Do the numbers depend on the specific tokenizing systems, or are they the same across LLMs? So I would say there are different types of tokenization techniques that are out there to use. And yes, they are different. They always vary. We will see about this later, about different types that there are out there to exist. I don't remember if I included different types of tokenization, because they are like different types. Like you can either divide by words, as for example in here I am dividing by words, but you can also divide by characters or bytes. So depending on how depending on the tokenization method that you use, it's the token ID that you will get. I thought you use vectorizers such as CFID or oh, okay, yes. I mean, that's also true. So would write and writing and road receive token IDs number that are close together? Yes, yes. I mean, mm, depending on the model that you're using, that is also true, and we will see this. Just give me a moment. We will get there. I think we are having experienced hackers in here, so I will try to move a little bit faster. Okay, so now going into embeddings. I like this definition that I got from a Medium article. It's very nice and it's very neat. So embeddings basically provide a way to represent complex data types, such as like text, which is what we will be using today. But they can also be images, videos, graphs, and so on, anything that you can imagine. And they convert it into a numerical format that machines can process. So right now, I hope this definition also sticks with you, because basically embeddings are just converting complex data types such as text, videos, images into a numerical format. And this numerical format or number actually means something and has some math behind that we will be seeing as well today. Okay, we have some question and answer in here. Vectorization method. Nice. Okay. So before you create them into character, you just process call, memorization, and stemming. Okay. Okay. This is complex. I mean, I'm very glad experienced hackers are around. The whole process is called pre-processing. Nice. Thank you for the clarification. That's right. I mean, what can I say? Yes. I mean, as you know, I always try to keep things simple. I know there are some more complex things behind of this. I know, and I understand you. Just that, yes, I will try to keep this as simple as possible for everyone, and we will be moving to the activity later on, which will be more. I wouldn't say challenging, um, but I will have a challenge for you all at the end. Probably not on this stream. That will be probably for part two. But yes, and making it accessible for everyone. Yes, no worries. Proceed the simplicity. Okay, yes. I mean that's what I am here for, and I mean probably I will actually take this as feedback. Probably in later streams, I will specify which streams are like beginners and which ones are advanced. So you can know from advanced like what to expect, and I can also know like what type of content to give. Because when I was designing this workshop for you all, I was thinking like, okay, this is not beginners week, but there are also like a lot of beginner and new hackers on the server. So if I try to like make it like super complex, like targeting experienced hackers, then probably a lot of people will be confused. So that's why I decided to kind of like keep it with I mean, like the most meaningful parts, right? But yes, I mean, definitely on next streams, I will specify which ones are like beginner friendly, and which ones are like for experienced hackers, and actually specify which technical knowledges you need to have before entering the stream. So yes, and I mean, I appreciate that there's a lot of hacker community that actually know these types of things. Oh, I think my video cut off again. But I think you are hearing me, so I will refresh my camera. Just give me 2 seconds. Okay, I'm back again. I don't think it's the streaming nor my internet. I think it's my camera because it's a new webcam, so probably it's that. Um, but yes, I mean, thank you. Okay, so let's continue. We were talking about embeddings, and there was a whole side conversation about super interesting topics that, I mean, I would actually love to learn more about that and also make a more advanced presentation later on. Um, yes, I also appreciate the simplicity. Yes, I mean, no worries. I specified on the Discord message that it will be beginner friendly, so that's what I'm trying to do here today. Okay, so now the question, why are embeddings important in all of this? So they capture the semantic relationships, and this is very important, the word semantic, because we are trying to find how similar two things are, or two sets of data are, not only in their spelling or their grammar, but more of like their meaning, so their semantic meaning. So try to remember that. Yes, try to remember the word semantic with embeddings, because embeddings give you like the semantic relationship, if you would like to see it that way. And what they also do is that they reduce data dimensionality. This may sound weird, but this is basically just that by converting I don't know, like a word into a number, you are reducing data and making it smaller, so computations will be faster. So this is also like more optimal if you are working with these types of things. So yes, this just basically means that by reducing this into numbers, you are making your computations much faster. And embeddings basically capture the semantic relationships in between data. And in here, you can find another quotation plane with different words and meanings. So we have examples here. So we have programming languages, and Python and Java are very likely to be plotted next to each other because they are not the same. I know that, but they are programming languages, so they are related, right? So they must be plotted really near in between them. Then we have another topic over here that it's royal, and we have queen and king. They are not the same, but they are still plotted in kind of like a similar setting. Also gender, woman and man. Okay, we have another question, a little advanced for me to grasp at the moment, but thanks. Yes, I mean, I also love your explanation. That is also something very interesting, and I appreciate that you have read so much about that. I mean, it truly demonstrates hacker spirit, and also all of the new hackers today. I really appreciate you for joining this stream. I know probably it might sound kind of complex, but now that you are seeing what it actually is, I hope you are understanding it much better. Yes, and I appreciate the positiveness as well. Python is embedded in Java. Okay, how? What do you? I think I didn't understand the question. Python is embedded in Java. I mean, they have similar embeddings, if that's what you mean. Yes, because they are both programming languages. So when you actually get the embeddings of those programming languages, you will see that the numbers are fairly similar. Rather, if you place like, I don't know, like Python and like coffee, they will be much different. So yes, I think I understood your question. I hope I answered it as well. Embeddings make it like diagrams for LLMs to understand. Yes, I mean, yes, embeddings make it easier for LLMs to understand the content that you're typing. Like if you are asking, like, oh, ChatGPT, what is 1 plus 1? ChatGPT won't receive like that sentence. ChatGPT will only receive like vectors of numbers that will mean your question, and ChatGPT will respond with that again. And there's a whole encoding decoding process going on in there for you to get an answer. But yes, everything is basically numbers, numbers and more numbers. Sorry for that. I would recommend looking it up, though. They are basically simple algorithms that make sure we have the root words and not so that write and writing are taken to be different words. Yes, I mean, that's basically what it does. And if you remember what I explained earlier, it's all about the semantic meaning. So write and writing we as humans and with our English knowledge, we know that write is basically like the verb and writing is just like the ing version of that verb, and they are basically they mean that you are like writing, but for a machine that's different. So the spelling is actually different. So there's a process in there that goes through. So yes, as for mentioned, feel free to research more about that. Are not taken to be different words. Yes, yes, I get you, I get you. um okay, a lot of okay, I will leave the side conversation going on because we have to move forward with this. Okay, so now kind of like the final part when we summarize, how do tokens, what we saw earlier at the beginning of the stream, relate with embeddings? So this is a nice diagram to have over here. I like it. And it's very similar to the one that we saw at the beginning on the stream that I just kind of like presented to you to watch. But yes, once a text is tokenized or converted into tokens, embeddings, which are what we already learned, the numbers, turn those tokens into numerical representations. And these numerical representations are called vectors. As someone mentioned at the beginning of the stream, vector embeddings are, I wouldn't say they're the same, but yes, embeddings are always related, are almost always related to vectors because they are stored in a vectorized form, or like an array, if you would like to see it in a more computer science kind of side. And we have an example here that says the word king might be represented as, and then it has a set of numbers, which are the embeddings. So these numbers are the embeddings, and it's basically values separated by commas, and it's an array. So this over here, it's an array, and it is represented as a vector, right? And these are called the different embeddings that represent the word king. Then in here we have another example with the sentence bovine bodies say. Then it goes through an embedding model, and then this sentence is transformed into numbers that are basically our embeddings, which are vectors. So right now you might be thinking, okay, cool. I know what embeddings are, what tokens are now, and I know they are like these funny numbers that are represented as vectors. But like, okay, how does that even relate to recommendation systems? So if you think of numbers, of this set of numbers over here, and I want to ask this to the chat before I explain it. This is a question for you to answer if you want, and if you don't want, I will also answer either way. So with everything that we have seen by now, tokens, embeddings, vector embeddings, and this diagram that I have over here. So I will place a case scenario, and you will tell me like your best thought, or best like um, conclusion about it. So imagine we have in here, instead of bovine bodies say, we have like two persons, right? And person one likes to eat vanilla ice cream, and then person two likes to eat chocolate with pizza. Okay, that's two different things and two different sentences, right? So we have two different sentences, and those two different sentences go through my embedding model. So the sentences are now converted into embeddings, and as we have learned, embeddings are basically numbers. Chocolate with I know, don't judge me. I don't eat that. Okay, I don't eat that, but that's just what came into my mind, so don't judge me. Okay, so we have vanilla ice cream and we have chocolate with pizza. Okay, so that goes through our embedding model, and those two sentences are converted into numbers, and those numbers are stored in two different vectors. Okay, so how are those numbers like related? Like, how would I know like what to recommend to someone? Like, imagine a person three comes and says like, oh, I like chocolate ice cream. Like, how will the numbers be related between the three persons? Like if I'm talking about a recommendation system and I have my three vectors, do you think like there's a relationship between like the three different vectors and the values of the numbers? Like for example, I mentioned pizza with chocolate, I mentioned vanilla ice cream, and then the person three mentioned chocolate ice cream. So it kind of has similarities in there. So would you say like there's like a similarity in between the numbers? And let's see the chat. You can start dropping your conclusions or criticize my chocolate with pizza. I know. I don't know why I said that. I don't know why I said that. Close in Euclidean distance. Okay, I like that concept. Keep that in mind. I like it. Cosine similarity. Okay, we have someone with the correct answer. Yes, it's cosine similarity, but I'm guessing you're an experienced hacker, so you might already be familiar with these concepts. But yes, cosine similarity. Yes, there is a similarity. Okay, that's so true. I'm still in chocolate. chocolate. I- okay, I will laugh. I will stop laughing now because that was very funny. I'm so sorry. Yes, there will be some similarity with both of them. Yes, that is true. K and N. Kind of. If you would like to see it with another different type of algorithm related to machine learning, let me think it through. So we have chocolate ice cream. Depending on the training data for KNN on that case. But as we are talking about AI, then we don't care about the training data. We only care about the numbers that we have. And as we have numbers, we will be performing different equations. And someone mentioned equi- I don't know how to pronounce that, but yes, that distance. And that is true. Yes, that is true. And also the cosine similarity thing is also true, which we will be explaining at the end of this presentation that I also included. Yes, there are multiple similarity methods. And yes, that is also true. Euclidean. Thank you very much. Thank you. Sometimes my English gets laggy. So sorry for that. Okay, so very happy that most of you got to engage on that part. Okay, so now we will be seeing the different types of embeddings that are out there. We will be focusing on this stream, and probably most recommendation systems focus on these types of embeddings. I wouldn't say that for sure, but that's at least what I have seen. So yes, it's cosine the angle between vectors. So I will explain cosine similarity in a second. Just give me a second so I can get through types of embeddings, and we will get there. I promise. So there are different types of embeddings actually too. We have static and contextual embeddings. Static, as the word says, basically means that it doesn't vary, it's always the same and it doesn't change, right? And then we have contextual embeddings, which are the ones that we will be using today, or at least the models that we will be using today. So some examples of contextual embeddings are BERT or GPT, because GPT also has its own tokenizer. But for this stream, we will be using BERT in a second. So yes, BERT is a contextual type of embedding. And what contextual basically means is that a word's vector or the array changes based on the sentence it is in. So yes, probably it's a lot to process right now. But yes, basically the vector or the array changes based on what is in the sentence, so the content. So going back to the vanilla ice cream and the chocolate with pizza. So chocolate, if chocolate is used with chocolate ice cream, it will have different numbers as it has on chocolate with pizza, because it is a contextual embedding, right? So the vector will change depending on the sentence that it is around, like the word. And I included this diagram. This diagram is not related to the contextual and static embeddings, but it's just basically how embeddings work. Um, oh, thank you. Yes, those are some example of static embeddings if you would like to research more about them. Thank you very much. Stream froze. Oh my god, no. I hope it is okay right now. I mean, I'm not getting any Wi-Fi warnings. So I think it should be good. Now mine is okay. Okay, then we're fine. We can see you just fine. Okay, thank you. Thank you. Okay, so this is basically I wouldn't say it's a graph, but it's a cute representation of how embeddings work depending on the types of different associations that you would like to assign different types of food or yeah, types of food. So we have desertness over here, then we have liquidness, and then we have sandwichness. I don't know if that's pronounced that way, but yes, basically sandwiches. So we have a hot dog in here, and a hot dog is more of a sandwich than not a sandwich. So that's because it has bread. So it's more like on the right side of the sandwichesness scale. And then we have a salad. And a salad is basically in the middle because it is not liquid, it is not as a dessert, and it is not a sandwich. But it has croutons, so that's kind of like bread. So it's in the middle, right? And then we have the apple strudel, and the apple strudel is over here because it is a dessert, and it is also bread, and it also has tomato. What did I say? Tomato. It also has apple. So yeah, some sandwiches have apple. That's why kind of like on the upper right corner. And then we have the soup over here, and that is considered liquid because it is more of like a cream, so it will be on the liquid side rather than on the sandwich side. Okay, we have more questions. Chocolate ice cream and chocolate pizza will be different for contextual embeddings. Yes, that is completely correct. I don't know if that was a question or a statement, but yes, that is correct. Is taco a sandwich? I would place it taco probably. Probably after the salad. Yes, probably after the salad. Because the pizza is more of a sandwich because it has more bread in it. What would the what would the pizza with chocolate fit in that graph? So I would place it probably over here because it is a pizza, so it's kind of like a sandwich, but it will also be placed like over here because technically it is also a dessert because it has chocolate in it, so it will be over here. Taco is like a sandwich. Yes, I mean it's more like a sandwich rather than a dessert or something liquid, so that's also true. How about a choco taco? So yes, choco taco will be over here. Sorry, I'll stop. Don't worry. This is actually the stream where I have laughed the most. I'm having so much fun right now. I'm having so much fun. It's actually a sandwich by the FDA. Okay, that is so random. Fun fact, but okay. It doesn't belong on the graph. Chocolate beans embedding. Yes. No one will ever forget that now. Okay, so yes, types of embeddings. Contextual, we will be focusing on contextual as I underline here, and we will be using BERT. We will get to try this on in a second. So closing on with applications of embeddings. So I know I talked a lot about what embeddings are and like the numbers and vectors and all of that like math stuff. But there are different types of applications where you can use embeddings on the real world. So the first one is semantic search. So imagine, and this is actually a super cool idea, hackathon project idea that I wanted to do, but I haven't found the time to do it. It's like it has happened to me when I am on my Spotify that I'm on a playlist and I try to look for a specific type of music. So for example, like pop music or like Latin music or like salsa music, but like it doesn't work. Like I have to search by the title of the song so I can get a result. So if Spotify implements semantic search on their search algorithm, if I search salsa music, then I will get salsa music popping out, right? So that will be cool to implement. It's a nice idea, and that's basically what semantic search means, is that when you search something similar in meaning, you will get a similar result. So if I search apple, I will get vegetables or fruits popping out on my search bar. um, yes, and embeddings are also used on recommendation systems, as we will be doing on this stream. Yes, to recommend you anything, basically. So for this stream, or these workshops, the recommendation system will be focused on kind of like a formulary where you will answer some questions and you will get matched with someone. So like kind of like going with the Valentine's team, it will not be kind of like Valentine's 100%, because I would like us to focus more in like the hacker spirit. So the questions will be focused on like hacker questions, like what is your favorite programming language, or what is like your favorite hacking hobby, or like what is your favorite keyboard, things like that. And another application of embeddings, which is probably the most common one, is multimodal applications. And I place here DALI as an example because, for example, ChatGPT, right now I can input ChatGPT voice, PDFs, notes, an image, a presentation, different types of data types. And the way that ChatGPT will understand that is when their uh, their information is converted into embeddings. So it has to go through that process, and that's why it's called multimodal, because it accepts different types of data from you or from the user. Semantic search for videos will be cool. Yes, I mean that's true. I see a fish. Oh, it's kind of like a goldfish. Yes, it's kind of like a goldfish. That's nice. But yes, I mean, I also agree on that. I I agree more in that it should be placed on Spotify. You have no idea how many times I have searched like a type of music on my playlist and nothing pops out. I mean, if no one codes that, I will for sure do it the next time I have free time. Um okay, so this is a long comment. Okay, so this is sort of a tangent. Feel free to skip over this. No, I won't skip it because now I want to read it. But this is reminding me of the time I was working with a JavaScript wrapper for sklearn, and my Python model had an accuracy of 93%. Okay, that's actually nice. And putting it through the TensorFlow JavaScript led to an accuracy of 9. Oh my god. And I was so confused. Spent a week deconstructing the library. That's so nice. I mean, when you actually go and see what's going on into their internal libraries, you know that you are doing something right or wrong. It can be either of those. And the error was with the vectorizer and padding functions. Padding sounds weird. And I tried so many stuff and none of it worked. And I remember getting so mad with the code at the end of the week. I just wrote my own implementation of the vectorizer and padding functions, and that brought my accuracy back and sent that. Oh, that's so nice. You should. I mean, I hope you already sent that because that's so nice. I mean, that's literally the definition of open source coding. You should definitely contribute more to open source. That's a super nice contribution. Nice, that's so cool. Why was your accuracy low for TensorFlow? I accidentally found a problem in Swift internal files. Then you should also contribute to open source as well. Okay. But closing up with this, yes, embeddings are used in multiple parts, but today we will be using them in recommendation systems. And oh my god, I just spent an hour talking. Yes, so now will be super brief. I promise, just two more slides to understand the basic math and to come back into the part where we mentioned cosine similarity. So let's get that through. So probably I'm hoping we all know right now what a vector is, and we already learned what vector embeddings are. And yes, this is related to vectors as we have seen in maths and physics. So as for math definition, a vector is a set of numbers representing, magnitude. and direction, because we have an angle and we also have a point in our Cartesian plane. And in this little cute picture, we have 1, 1. So that's no, don't get scared. This will be super easy, I promise. We won't be doing any math homework today. We will just understand what a vector is. So we all know now that a vector has magnitude and a direction, and we can see it on this nice graph. And then talking more about embeddings and how vectors actually relate to that. So we can call these complex vectors because they are in kind of like a multidimensional space. So in school, we probably just saw like 2D spaces with our Cartesian plane in X and Y, or probably up to three dimensions, X, Y, and Z. And if you want to see it more in like a computer science sort of things, you might want to think of a vector as an array. So if you are learning programming, I'm pretty sure you have learned about what arrays are, and this is basically a numerical sets of data that are stored in kind of like a parentheses or brackets. So we call these complex vectors because they are not very understandable, or even like they cannot even be seen by human eyes, but they can be understood by machines because they have different multidimensional spaces, and they are all like plotted into different points on space with different values. And yes, that's basically what this means. Jocelyn GPT for making math easy to learn. No, I will get you back. I promise. This will be our last slide. And this one, I will have to say and break this to you. This one is hard. Okay, this is hard. When you try to do it like by hand, not like understand it. Understand it is like super easy, and you will say like, oh, cosine similarity. Okay, this is a super nice formula. It looks cute. In Python, I can basically do like a function dot cosine similarity, and bam, like that's it. And you will see that when we are coding our Python script. And actually, there's a lot of math behind of this that deals with all of our arrays of vectors, and that's just basically how it outputs a relationship between our numbers. So going back to my weird example of vanilla ice cream at chocolate pizza, so to actually get a similarity or a result of these two sentences, I will have to place those two sentences or and represent those two sentences as vectors. So let's imagine that vanilla ice cream is A and then chocolate pizza is B. So those are two vectors, and when I do this formula, I will get the similarity in between those two vectors. It is as simple as that. Um, it's not very hard to understand. You just have to picture it with an example, so you can actually understand, what is behind of it. So now, when someone tells you like how those embeddings actually get like the relationship in between things, you can now say, oh, it's because of cosine similarity, and this is actually a super cool formula that helps to do this and this and that. And you can now be like kind of like the nerdy person that explains how this works. So yes, this is everything that's behind of it. Is length of vectors. Yes, that is so true. Dot product finds cosine similarity between two things. Yes, that is also true. Okay, I'm getting yes. I'm so glad. I'm so glad we are all on the same page. Okay, but going through the slide, this formula is just basically to measure the similarity between two vectors or two sentences, two words, two somethings. Okay, and then it calculates the cosine. So cosine, if you remember from math, the thing in your calculator that it's like cos, like cos, calculates the cosine of the angle. So the angle of my vector, like how it opens, the angle between the vectors, which represents their direction. So where the arrow is pointing, okay? In a multidimensional space. So we are not talking about 2D space. We are talking about many spaces, so multidimensional space. And this formula it will basically give me their relationship between them, like their similarity. That's why it's called cosine similarity, because it uses cosine to calculate um, the similarity in between two vectors. And this is basically it. It's a dot product in between a and b, and then it's the magnitude or length of the two vectors, and also their dot product of those two lengths, and then their division of it. And in most programming languages, you can do this super instantly just by importing a library and using cosine similarity function, and you will get it if you give two vectors as input. Um, Sign similarity is not used. A sign is zero and two. Yes, that's a nice math reference. I like that. Do you have an example? Um, yes. I mean, I think I can give you an example of what we saw before. So right now in this formula we are seeing like a and b, right? And in here we have a, b are the two vectors, right? So let's imagine that a is the vanilla ice cream that I mentioned before, and then b is my chocolate with pizza. So a, vanilla ice cream, b, chocolate with pizza, right? So I know these are sentences and they are words, but then these words I will pass those sentences through an embedding model, and that embedding model will give me those sentences with numerical values. So then I will have two arrays or two vectors with different numbers, from different numbers. And then when I calculate those arrays with this formula, I will get the similarity in between them. So I actually had done this by hand for a school project. And damn, I actually wanted to show you like the paper that I worked on. Probably if I find it, I will share it on the Discord, but you will have to remind me. Like try to ping me after the stream so I remember and send you like the pages with the mathematical calculations so you can see like how to like an actual numerical example. And that example was actually related to movie recommendations. So it's pretty similar. When I converted my model from the regular PKL to, oh, I don't like Onyx models that were well enough. The problem was when the vector is a library. Okay, this is related to your open source contribution, which I am very proud. Makes sense. Yes, no worries. I'll ping you. Yes, please ping me. Ping me on the general or whatever. If you ping me, I will see it. I check my Discord like 24/7. So except when I'm asleep, which I also sleep. Okay, and also another important thing to know in here is that my embeddings and my outputs for my recommendations will give me a value, and this will always be in between -1 and 1. And if you get a 0, that means that like no. Okay. So when you see the embeddings, you will always see that they range from numbers from -1 and 1. That is actually a nice trivia question, like asking like what are the range values for embeddings. It's a tricky one, but yes. I hit Onyx after that too. Yes, I don't like them. I think I have also used them for spotting keywords on speech. So I train like some models that were for waking words. So if you have like an Alexa or like a Google Home, you or like Siri, when you say like hey Siri or like Alexa or like okay Google, so those are like wake words. So I train like my own model so it can respond to the word Frida. And I had to also go through a pain with the Onyx models, which I would not be talking more about that. Okay, yes. So cosine similarity is the last thing of math that we will be seeing today. And yes, now to the activity part. I know I talked a lot about the presentation slides thing, and now we will go into the coding part, which is the fun part, if you would like me to admit that. And what else? So for this stream, as we have about 15 minutes left, we will be doing the following. So we will create our own embeddings. This will be kind of like a practice exercise. Then after that, I will explain you how Streamlit works and to have your nice landing page. with example questions, and that we will actually be drafting together. And then for the part two of the stream, which will not be today, we will be implementing all of the concepts that we learned earlier about the recommendation system, so we can actually create that. So for the part two of the stream, I don't have a date yet because they have not confirmed me yet, but most probably it will be on Wednesday. I will be sending you a reminder that it is a part two of our recommendation system. I know there's still a lot of days to go, so I hope you don't forget everything that we talked today. I will try to do my best so the part two is sooner, probably by swapping one of my other streams that I have on. Monday or tomorrow. But don't worry, I will let you know about any update on the schedule on the Discord as well. I have I've never tried to do AI ML in JavaScript. After that, always use a Python server. Yes, that's also what I wanted to mention. I mean, I've never tried JavaScript in that in that sense. Talking a lot is good, fun is important. Yes, I mean, I love the side conversations and everything that we've seen this. Can you paste it here, please? Um, paste. Oh, yes, the link. Yes, yes, I was going to do that as well. Thank you very much for writing it. Thank you. Hi for four. Is there any open source contribution platform you can suggest? Oh, yes, that's the model that we will be using. I do have to drop off now. My laptop battery is dying soon, and I promise Cecilia I will get sleep. That's very nice. Good night then. Look for GitHub projects that have a license. They're typically open source. Yes, that's also true. Jocelyn, should we do AI ML is assembly? Should we do AI is assembly in assembly? No. Please don't do that. Please value yourself. No, please. No, 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 no. Okay, so let's get started with the activity. I will exit from the. Oops. Nope, this is not the slide. So we stay on here and let's access this link. I think. Oh no, I think someone already sent it over on the chat. If not, I will send it again just so you can keep it in mind. This is a short link, so when you paste it in here, hopefully it will direct you to the correct page. Oh yes, it worked. Yes, because I actually didn't test that before. So I should have tested. Okay, I will. Yes, let's hide this. Okay, so this is just a super basic example, and I will make my screen bigger because I know it's like super small. Okay, I think that's better now. Okay, so this is a super basic example of how a tokenizer with an embedding model works, and it is very simple. I mean, right now you are seeing just like what, like one, two, three, four, like 5 lines of code, and these 5 lines of code basically cover almost everything that we saw throughout the presentation. So if you see when you see like the code, it's very simple, and you can say like, oh, okay, this is my sentence and my embeddings. Cool. Okay, my embeddings are encoded. Nice. I have my random numbers now. But after the presentation and the stream that you just watched, now you will be able to know like where the embeddings come from and what those numbers actually understand and the whole process that is behind the code. So you can now be like super pros when someone asks you something related to this, and you can answer them super promptly. So for this, you have to install the library Sentence Transformers. It's the most commonly used by Hugging Face. So for some of you who don't know what Hugging Face is, Hugging Face is nothing more than a super cool platform for all of those who are searching for AI models, machine learning models, everything related to AI. It's in there. And actually, let's go and see what Hugging Face is. Let's try this one. Yes, Hugging Face models. And you can find pretty much any model in here. And the most cool part is that they are open source, most of them, because for some of them you need to gain access, but it's usually not very hard. I mean, most of them are built by the community. And if you see here, we have DeepSeek, which is kind of like the trend right now, and we can actually go in and see like the different files that they have, and we can see how they actually train their model. And we can also see like if I want to use it and I select transformers, and I get like uh a nice example, code example of how to use this model. So yes, I think someone, yes, GitHub for models and datasets. That's a super great definition. That's all. We get free hosting too. Nice. Yes, so Hugging Face is nothing more than a super cool place where you can find free models and also datasets as well. And it is a platform, so it is not like a library or something. It's more like a platform where people post their models, and you can contribute to them as they are open source, most of them. So yes, this sentence transformer things comes from Hugging Face, and if I actually go ahead and search for this, there it is. This is the one we're using. So in here we have sentence transformers, and we are using this model, all mini, and what else? And this is the one that we are using. So as I specified here in the comment, there are different models that we can use to transform text into embeddings. And this is the model that we will be using, which is this one, all mini. And there are different ones. I mean, here is actually another example. You can also copy paste that and test it. Then what is this? Using transformers, mean pulling. Yeah, no, we don't need that. Yes, so this is where I got the model from, and then I just basically typing my sentences. Let's actually try the vanilla ice cream thing. Uh, Vanilla ice cream, and then the chocolate pizza. Let's see what it gives. Yeah, so feel free to type any sentences that you want, and then we will be obtaining the embeddings using the encoding function from the library. And yes, I store this in a variable called embeddings, and then I finally print them. And when you print them, you will see like arrays of numbers that vary from -1 to 1. What does it says? Can any specific reason for using this model? Honestly, as for my preference, no. I would even recommend you to use different ones. Yes, honestly, I don't have any preference, so no worries if you try to use a different one. For the activity, I will actually use a specific one, but also I don't have any preference if you change it as well. Can we exchange the weather? Oh, like what is the weather right now in Mexico? You mean that? Can I copy these commands into a Python file in VS Code? Yes, you can do that. Except the pip install sentence transformers. This one you have to install it from the terminal. Yes. Okay, yes. So right now we are 23 degrees Celsius. Yes, it is a great weather. Yes, I mean I was in Montreal like for a hackathon last week, and it was -20 and -15 degrees. That was like that was crazy. I mean, I'm not used to very cold weather, so that was very new for me. I'm at -4. Oh, that's cold. No, no. Here it's warm. I would say warm slash hot. So yes. Okay, so let me run this again. What I create? Oh, okay, yes. Hold on. Have to change my account. Yes, probably. I think it will let you run the code in my Google Colab. Probably not edit it, not very sure, but you can make a copy of it or just add it in your Python script as someone mentioned. Let me do the uh ch- and then the chocolate pizza. Let me run this again. Probably have to run the other ones again. Shoot. Um, well, let's wait for that. Yes, hold on. Let me import this first. Yeah, so I mean, this is just a simple example. We will not be using this for our activity. But I just want you to see like specifically like how embeddings look like and how you can actually get like those numbers for yourself. So when we actually use them on our project, you will be like, oh, like yeah, they are similar, right? Um, this is taking a long time. Oh, I mean, it's just importing something. Why is it taking so long? I mean, it's not even like training something. Yeah, there it is. And then this is done. Embeddings are so. Oh, there it is. Oh, and you can see tokenizer config. So now you know what tokens are. That is done. So now let's print the embeddings. And let's see how they change. I mean, they actually changed a lot. I'm impressed. And they are like super tiny numbers, like because we have like E. Amazing. Okay, I mean you should all be getting different numbers. I just want you to see what they actually look like. So when we use them, you will now understand like what they are. But yes, I don't know if there are any more questions about this before we go on into the Streamlit part, because now we will be moving on into a completely different topic, which is Streamlit and Python. So if there are any more questions or comments, we can proceed in the last 40 minutes that we have today. I'll give a moment for you to think. Mm-mm-mm. I think we're good. Okay, so I will close this now. Now, as I always like to do in my streams, I will share with you a GitHub repository where I will be uploading all of the code that we will be creating during this live stream session, and you can feel free and clone these. Um, but just remember that if you want to contribute to the repository, please make another branch and make a pull request so I'm aware. And yes, I mean that's all. You should be able to create branches as well. If not, you can tell me. What else? You can also feel free to copy paste the code that I will be uploading here and use it in your own repositories. I will strongly recommend for you to create your own repository so you have kind of like your own version. Jocelyn forking. Yes, you can also fork it. But I usually don't recommend that because then people kind of like get confused between cloning and forking a repository. My personal recommendation: create your own repository and just copy paste what I'm doing here so you can have it in your profile and it is like 100% yours. Yes, that is my recommendation. So let me share this link with you. Whoop, there we go. So it's called Valentine's Tech because now I have a lot of repositories that are called LLM something or AI something. So I just wanted to change the topic for this. And yeah, this is just kind of like the stream description, and then I created this readme that has the features that we will be covering today. So right now we did this, we just learned what are embeddings and tokens, and this was meant for the first session, so we already covered that. And for the rest of the stream, we will be constructing our interface. And yes, I think we will have time to deploy it. Not sure. I mean, this only takes like 10 minutes or 5 minutes if we do it fast. And for the second part, we will be doing this too. So interacting with MongoDB and building our recommendation system method. So the recommendation system method is super simple. It's just like a Python method, and I'm it's not even like I think it's not even like 60 lines long, depending on which library we use. But it should be pretty straightforward. But still, I would leave this for the part two of the stream. That will be probably on Wednesday if I cannot move it sooner, tomorrow or Monday or Tuesday. For the project in that post, we have to do more than this. Can you specify which specific project on the post, please? Yes, and then this is to run your Streamlit file, and then here are the slides that I was presenting today. So these are the Google slides about the embeddings and tokens thing. And then this is in here I will upload the YouTube recordings in case you want to access them as well. Okay, so I will clone my own repository. Again, you don't have to do this. I'm just doing this because I want to have it in my local environment. I will recommend you to start your own project, like open a new folder and start creating your own files as I am doing that today. Oop. Yes, I will make this bigger as well. Okay, so clone Git repository, and I'll paste my own link. And then I'll just select probably desktop. I'll just this is so funny. I mean, I don't use this laptop anymore. I only use it for the MLH streams. But this used to be my high school laptop, so I'm just seeing here. This basically means code that actually works for my homework. It's a really funny folder name. Yes. So I already cloned my repository and I'm just opening it. Don't worry, you don't have to do this. I mean, just open a new folder in VS Code with file and then new window, and then you just open a folder on this side, or create a new folder if you want. Let me just close this, pop in the VS Code bits. Okay. Yes, so right now we only have these three things. It doesn't matter if you don't have them, we will be creating them along the way, especially the git ignore. This will be important for the part two of the stream. Okay, so by this point, everyone should already have a new VS Code tab with a project open, probably a file created, probably not. For the okay, I have the answer here. For the project in dev post, we have to do more than this recommendation system. Let me go right now and check that. I didn't even know that was a thing. So challenges, let's see. Sign up. Star your favorite project. Customize. Oh, these are partners. Beginner, share your MLH sticker swag, explain AI to a 5-year. Oh, this is cool actually. Document summarizer, logo challenge. It was there in it was in the post partner, really? Build and run. Oh, you know what? Build your first recommendation system. Follow the building a recommendation system track and submit your hack. Oh yes, you can place this one as on dev post. You can upload this repository to dev post, like the one that you will be creating today. It would not be finished on this stream, so you have to join the part 2 of the stream. So yes, this is also part of this. And actually, for tomorrow, I will be giving 2 streams that will be covering this challenge in case you want to join. And also this one, create your own AI chatbot. That's literally my my stream. Yes, so you can basically apply to this, and for this stream, you can apply to this. Yes, thank you for noting that. Also for everyone. Okay, so for the Streamlit part, let me go and share the documentation of a Streamlit. So I didn't prepare the slides for Streamlit because I thought it wasn't necessary. I mean, I think we can cover it with their documentation page. Let me share that with you. So basically, Streamlit is a Python library. It is something that you can import into your code to make it prettier, to make a nice interface, to make it kind of like a web app, and a really nice web app with very simple steps. It is, I wouldn't say Streamlit is a framework because it's not, it's a library. Um, yes, and it is also open source in case you want to contribute to it. That's also true. So let's go to the installation. For this, you only have to do pip install Streamlit on your Python environment. I will make that bigger. So pip install Streamlit and then Streamlit hello. So you can validate installation of the Streamlit. I won't be running that today, but just keep in mind that you have to install it using a pip command. Great. What else? Let's see some simple concepts. Up design, probably. No. Oh, fundamentals. Here we go. I don't like these examples, actually. I don't like this. You know what? Let's do them ourselves. But this is a docs page in case you want to explore further. But let's just get it started, so you can see how easy it is to do it. You can just follow along with me to get our application running as fast as possible. So I will create a new file and I will call this file home.py. And then on this file, I will import Streamlit as we already saw. It's import Streamlit as st because I want to call Streamlit as st. And then I will write my first title, which will be st.title. Oh, there we are. I think I'm back. Yes, I'm back. Wow, my internet like lagged for a second. Okay, so you just import the Streamlit as st and then just type a title, which will be title, recommendation, well, hacker spirit plus Valentine's recommendation system. There we go. And that will be our title. You can place another title if you want. I'm just placing this for some guidance. And this will be our title. And if you can see right now, we only have like one line. And let's run this to see how it looks, so you can see how easy it is to get started. So if you haven't used Streamlit before, you have to install it. So to install it, it's pip install Streamlit and then enter. I will not run these because I already have it installed. But if it's your first time, make sure to have it like that. And then to run your application, it's a Streamlit, a Streamlit run, and then the name of your file. So the name of my file is home.py. So home.py. And then you click enter. And let's see, it will load and it will open up a new page. Can we use a virtual environment? Yes, I always forget to do that. Thank you for reminding. But yes, 100%, please use a virtual environment. I mean, I'm not using one right now because I forgot, but that's a nice practice. Thank you for remembering that. Nice. So now it loaded and it will open up a new. There we go. So this is how Streamlit works. It is super simple. Now I have a page that has my title, Hacker Spirit plus Valentine's recommendation system. I think it's a long title. I'll probably change it later. But yes. No, I clicked on the cross. Oh, that's how. Okay, yes. Let's wait for my VS Code to open again, because I accidentally clicked on the cross, and now it's taking ages to load. But yes, as you can see, it's very simple to get started with Streamlit. I mean, I just basically placed like ST and then dot title, and then it gave me like a whole page. So it should be as easy as that. So let's start building our interface. Let's add a divider, and divider will just basically be like a line on my content. So st divider, and that will be a line. And then I will add a text that says fill the questions so you can get a match. Great. And then after that, let's add another divider. Well, no, let's add an image. Why not? Let's add an image. So let's search for an image online and also reload this. Let me reload the page. Let's see if it actually works. Oh, I think it's connecting. Nope. Let me run it again. To see how it looks, then we will add an image, and then we will add the questions that we like to answer. Oh, what? Why are so many errors? That's so weird. Okay. Let's see. Great. So Hacker Spirit plus Valentine's recommendation system. Fill the questions. I have to fix my spelling. And let's set the image so we don't get this error. Fill out the questions, and let's search for an image online. What do I like? Valentine penguin. Let's see. I don't like this. Huh. Oh, I like this one. This is very nice. Let's try it with the direct image link. If that doesn't work, or if it's too long, probably will be too long because I'm too lazy to save the image. So I'll just copy paste the link and paste it here, hoping it will work. Sometimes it works, sometimes it doesn't. Oh, yep, sorry. How to place the. Let's see. I mean, I actually don't remember if it receives URLs. Let's find it out. Oh, there it is. Nice. So we have a nice image of my penguins. Great. And then after this cute image, actually, let's delete this text and place it below. So let me delete this. And let's make it a subheader so it's bigger. So st dot subheader. No, subheader doesn't exist. Subtitle, does that exist? No, subheader. Yes, subheader exists. And then fill questions below to get your techie match. There we go. And now let's reload this to see if it's updated. There we go. Fill the questions below to get your techie match. Great. So now let's add the questions. So for this part, keep in mind that the questions that we will be using on these forms or on this page, these questions, the answer to these questions will be converted into embeddings, and then we will calculate the cosine similarity between the different sentences that we have in order to perform a match between someone else and you. So the questions have to be things that we actually want people to get recommendations or matches from. So, how did you get that little cat running on the bottom? It's so cute. So, that's an extension. It's called VS Code Pets. So, VS Code Pets. This one over here. Oh, there's a VS Code Pokemon? Huh. Yes. Trust Publisher install. Ooh, thank you for asking that. Because if it wasn't for you, I wouldn't have discovered that there was a VS Code Pokemon. What is this? Puts cute Pokemon in your code editor to boost productivity. This is so cute. And then how do I use it? Command Shift VS Code Pokemon, search for Command Shift P. Ooh. Okay, let's test extension at the end. Awesome. Gotcha. Catch them all. Yes, yes. Okay. So let's start drafting our questions. Right now, I can think of some questions that I would ask someone in the tech world. But if you have your own question recommendations, please leave them on the chat and I will be placing them in here. So, first question will be, let me see. Favorite coffee. This will be a variable st text input, and it will be what is your favorite drink to order at a coffee shop. Okay. Can you send the image link? I love the image. Yes, of course. Let me send it. You know what? It would also be cool to add a GIF, like and also make it PNG, so it doesn't have like the weird background. But I will also change the background of the Streamlit to pink. Probably at the end. We will have time, very sure. There it is. Yes, it's very nice. Okay, so the first question is favorite coffee, favorite keycap. What, you know what? I want to activate GitHub Copilot so I don't have to type all of the questions because this is a type of task that Copilot will do for me. What is your favorite keycap for mechanical? If someone has questions, this is the time because I am running out of ideas. What else? Oh, favorite programming language. That's true. Oh my god, I don't like my keyboard right now. Text editor. Oh yes, that's also true. Text editor. I mean, what else would you ask someone who is like in the tech world? Probably like how many hackathons have you been to? I'm not sure. I mean, because that will be a number. So in embedding some number, probably which hackathons have you been to? That will be a better question to ask. Mm, there we go. Favorite snack to munch on while coding. Ooh, I actually was going to bring some Lucky Charms on the stream, but I forgot. Because I would say that's my favorite snack right now. Because I always change snacks. Favorite snack. Okay, let's just add three more questions and we're good to go. Just so we have something more reliable, you know? What is your favorite snack to munch while coding? And then the other is, what's your favorite browser? Ooh, that's like a super important question for me. I mean, I take that question very seriously because I care a lot about which browsers I use. So, I mean, I think there was a point. Well, no, I'm not. I'm not going to. I'm sorry. No, that wasn't. Let's forget what I said. St dot favorite. What am I doing? Why did I place time input? That's not time input. That's text input. I mean, I just feel like a robot right now, like typing the same things. I mean, people, if you want to use AI in something, use it in things like this, like repetitive tasks, you know, that you don't want to lose your valuable time doing. Uh, what is your favorite? So now I want to drop this question on the chat. What is everyone's favorite browser? All of us must answer chocolate pizza. Yes, on the favorite snack. Oh my god, 404 would disagree on that. Okay, please keep the comments under the MLH guidelines, please, because I don't want to ban anyone. So please. Favorite browser, Arc Supremacy. That's so true. Loki arcs on Windows is, oh yes, I wouldn't do that. I wouldn't do that at all. That would be so annoying. Safari, all right. Brave, yes, I agree with you 100%. And that's probably because you already saw me using it. But there's also Opera. I used Opera. Um, Chrome, yes, I give my data away. I think Opera is worse. Is worse. Yes, I think Opera is worse than Chrome. So you don't have to worry too much now. Okay, so favorite browser. I think we're good with these questions. If we have more questions, we will add them later on the next part of the stream. I don't like Microsoft Edge. Yeah, me neither. Internet Explorer is the goat. Yes, Brave and Chrome. So true. Firefox. Oh my god. Okay. Perfect. So let's refresh our page to see the questions pop out. Nice. So now we have our cute questions in here. And let's add a submit button. So to add the submit button, let's make an if case because we want to check when the button will be pressed. So if my st.button that it's called submit is pressed, then I will be sending the recommendations function. So I will add a comment that in here I will include my recommendation function, and then I will display a success message. Success match has been found. Yay. And then else I will click on st.warning. Please oh, please, my dog is sleeping in a very cute position. Hi. uh please, what was I going to type? Please fill all of the question blanks. There we go. So in here we basically have kind of like all of the front end that we will be needing. I mean, I'll probably make it a little bit more Valentine's themed for the next stream, so you can all follow along with that. What else? Keeping in mind that in this if else case, we will be adding our recommendation function in here. So in here, let's just imagine I would just have like a recommendation function that will receive all of my submission data, right? So this will be a function that we will be creating below over here. You don't have to worry about that now. For now, let's just keep it on with the front end and with these questions. I mean, that's why we were storing the questions in variables, so we can use them later for our own use. So let's refresh this, and we should be seeing our submission button. So there we go. Please fill all of the question blanks, and now I will be filling this random. Submit, match has been found, yay. And in theory, in here, we will be seeing like the match that we have depending on our answers. Okay, so before I go on with the next part, because we are actually running a little bit out of time. So yes, just so you can keep in mind what we will be doing for next stream, which will be very important. And let me upload this to GitHub while I'm doing that. So set up front end. So for the next stream, we will be making our recommendation method. Keep in mind that this will be super short. I will only take like 30 minutes or probably 20 minutes of the stream to build a recommendation method. Then we will be adding that recommendation method over here. After that, we will be creating a vector database on MongoDB, so we can upload all of our submissions up to there. So by doing that, we can all contribute to the same formulary, and we can get the recommendations in between the people that are on the stream. So that will be actually interesting to watch and to put our recommendation method in practice. As I mentioned, we will be most probably using cosine similarity, so we will be applying those concepts in there. We will also be using a tokenizer that it is called BERT. In case if you want to research a little bit in beforehand. But yes, recommendation function, we will be polishing a little bit more of the front end. Yeah, because I don't think we have time to do that right now. Probably yes. I think we have time to change the background to pink. Because to do that, we have to add a config file. So the config file, let me search for it, because I just want to copy paste it. Let me search it. Config files. Oh, Streamlit. There we go. So I can change the background of my application to to pink. Config.toml. Oh, here we go. Team. Let's change this. So to change the background of the app, create a file that will be called config.toml. And then you will copy paste this. I can share this as well. I will upload this as well. I think this looks weird. Oh, before you create, okay, so create a folder now that will be called dot streamlit. So dot streamlit, and then move that file inside the dot streamlit folder, just like this. So dot streamlit and then config.toml. And let me upload this change to GitHub so you can all see it. Just check if there's not like another stream right now. Okay. So I already uploaded the config file if you want to see it. And background color black, let's change that to pink and let's see if it changes. If not, I will specify a different color. Oh, what happened? That was weird. Okay, here's my app. It didn't change to pink. Okay, but also my stream is lagging, I think. Or at least my computer. Okay, someone shared their. Oh yeah, can you send the codes in chat? Yes, they are on the GitHub repository. No other stream. Oh, okay, yes, thank you for clarifying that. I mean, also I think we are. Yes, I mean I'm really not sure why the color didn't change. Probably because it has to be. Let me search for the hexadecimal value of pink. Hexadecimal color pink. I just wanted something to copy paste. Sad. Okay. This is nice. Let's copy paste this one. Place it in here. And let's see if it works. But it says you were 1 hour on the calendar. You were 1 hour on the calendar. So bonus. Oh my god, is that true? is this was supposed to be like 1 hour stream? No way. That I can't believe that now. Huh. That's weird. But it says you were wanna. Okay. Let's see if the color changed. And if it doesn't, then I will research what's going on. Because that's weird. It should be working. I mean, I've done this before. Custom theme. Oh, there it is. Yes. So you have to select custom theme over here. Now it looks more Valentine style. Awesome. So I think we can wrap up with that. Yes, I already made the last commit, changed to pink, and I will show you where to find the code so we can wrap up. There we go. Okay, so going back to the GitHub, you will find the code on the link that I already sent on the chat. I think someone sent it again. If not, I will send it over. All of the code is in here on the home.py. You can find everything that I typed on today and also the configuration file over here. in case you want to do something similar. I encourage you to do so. And yes, for the next stream, we will be basically creating the recommendation method, and we will also be polishing a little bit more on the front end, and we will be connecting into MongoDB. And I will keep you posted on the next stream and the date so you can all be aware of that. If there are not any more comments or questions, I think we are ready to close. Yes, because I think at least in my time zone, it's getting late. So, good night, everyone, and I will see you tomorrow. Because tomorrow I have another stream that it is creating your AI chatbot on Streamlit. So I will try not to make it generic, and it will not be generic. It will be cool. I promise. It will have a spin of fun. So, yes, good night, everyone. Please rest or have a super great day afterwards, and make sure to assist to the other different live streams that other coaches and streamers have prepared for you. Bye, everyone.